Okay, another aspect of C++ that's a little bit different than C is how memory management works. In the C language, when we want to allocate objects on the heap, we use malloc, and we use the free function to deallocate them. But in C++, we're going to use two new keywords called new and delete. So when I want to allocate something, I'm going to use new. So for example, if I want to create a new integer, or I want to allocate memory for an integer in the heap, then I would do it as I'm showing here on the slide, where I say new heap. And I say x equals new int. Okay, and in this case, new is a keyword function. And this will allocate exactly one integer. In C code, when we call malloc, we have to tell it how many bytes to allocate, but here we don't, because the C++ language knows how big an int is, and it's going to make sure that it allocates the right amount of space for an int. And since we just write int right here on the line, it can do that calculation for us. Here are some other examples of using the heap. Of using new to allocate things on the heap. Let's say I want to allocate one double, then I would say new, and I would store this result into some sort of variable of type double pointer. And let's say I have some struct called b, and it has some fields inside of it. Just to keep it simple, I just have one field in there called ball, just because I thought it'd be fun to have a struct b ball. And so here, when I allocate the struct, I would say new struct b, and this would allocate exactly one copy of the struct b. And then hopefully, if you recall, if you have a pointer to a struct in C, then you use the arrow operator to access one of its fields, and so b arrow ball equals 0 to set the ball field inside this struct equal to 0. And then we can also use new with an object. So let's say I have this class called R, and if I want, and inside this class I have a constructor. I know that this is a constructor because it has the same name as the class, and this constructor can be used to initialize the X member variable. And so I can call new and name the class, and in parentheses here I pass in the argument, the value that will be used by the constructor to initialize the object. And this will create a new object of type R, or an instance of R, initialized with the value 10. And in order to access the member print, again, just like with a struct, the way you would use the arrow to access a field, we use the arrow to call the print member function, and this would print out the value 10 by calling printf inside this member function. The key advantage to new over malloc is that when you call new, it can also perform initialization of an object by invoking the constructor, right? And we saw that on the previous slide. When I say new R, and in parentheses after it, not only does it allocate object R, it calls the constructor and initializes it. Malloc can't do this. Malloc just reserves memory. It doesn't also initialize memory. And this is the key reason C++ needs the new keyword, so that when you allocate space for an object, you can at the same time invoke the constructor to initialize the object. And this guarantees that object allocation and initialization happen together. And that's good for correctness. We don't want to delay the creation and initialization of objects unnecessarily. Now, anytime you allocate an object, you might also need to deallocate it, especially objects. And so for anything created with new, we eventually, when we no longer need it, should use the delete keyword to deallocate it. So here, after I create a new object, sometime later in my program, I want to use the delete keyword and then name the object I want to delete using its pointer. So delete R will the object from the heap. Okay, delete does more than just free the object. It also calls a special member function called the destructor. And the destructor is kind of the opposite of a constructor. It's what runs when the object is being deleted. And really, most of the time, for simple objects, there's not much you need a destructor to do. So for example, here, if I'm bringing back up our rectangle, when we construct it, we just set the length and width to be the values we want. But here where I create a destructor, and the way I know it's a destructor is it has the same name as the class, and it begins with this little tilde in front of it. And that tells me this is the destructor that runs when this object is destroyed. A destructor has no return value, just like a constructor, and it also is not allowed to take any arguments. Okay, and then when this object gets destroyed, it runs whatever code is inside the body. So in this case, we're just going to run a print statement that says, I've just been destroyed. Kind of, not a very useful thing to do, but at least it shows us that we can make an action happen when the object is being destroyed. Okay, and that's a nice thing about delete, that delete not only frees the memory for the object, but also will run a little piece of code that's in an object's destructor. Okay, as an example, let's design a class that prints a message when it's created and when it's destroyed. And the idea is that we'll pass a string to the constructor, and we'll print the string on construction, and then we'll print it again on destruction. So for example, here's a class called verbose, and it has a public member variable called message of type string. And then the verbose constructor takes a string as an argument, m, and the constructor will store m into the message. And then it will print out the message, an extra character string that just says I'm born. And then when the object is destroyed, the destructor will run, and this destructor will just print out, actually this is a smite bug, this should be message. We'll print out the message followed by I'm gone. Okay, and then when we create this object down here in main, we need to pass in a string so that it'll be constructed properly. In this case, I just pass in the name of the variable as a string, and that way the printouts will tell me about this variable. And so what will happen when you run this program, after you fix this and recall m message, it'll print out v : I'm born, and then right before main exits, it'll print v : I'm gone. So it's a cute little program. And the interesting thing here is just from this class that we created, it doesn't look like much would get printed, but actually the constructor is going to print a message and the destructor is going to print a message just before that object is destructed. Okay, summary of new and delete. We use new and delete to allocate and deallocate memory. New and delete are designed to work with objects, whereas malloc and free are not, right? And what we mean by that is that new will call the constructor for us, and delete will call the object's destructor.